Morning everyone, this is Nishchhal and here I'm going to talk about RAD at home, a presentation for the science day at GMRT. First question, what is this RAD at home? It's a Facebook group. It's a Facebook group where we study collectively, we post something regarding astronomy, we discuss the physics of it, astrophysics, and then we progressively learn a lot. Next question, why RAD at home? Why should you join RAD at home? Well, we work through commenting, sharing and liking Facebook posts. Now Facebook is an addiction nowadays, and if you're doing something productive out of Facebook, it is surely worth the mention. Then one-to-one discussion on objects or whatever we post through the comments. Obviously, if someone comments, other person likes the comment, they say that okay, this is not wrong, this is the right, then blah blah blah. So we interact a lot because Facebook is so far the best interactive media we have seen. Next, okay, we did a poster presentation in Pro M3 of some 20 or something posters. 11 were from RAD at home, or more than 50% were from RAD at home. So that is a success story. Second, we also submitted a proposal to GMRT, and that is something we can really boast about because I'm not, if you take me, I'm not even a passer from my undergrad course, and I've filed a proposal for GMRT. That's a big achievement because of RAD at home. Still, you ask, why RAD at home? What can be its impact on my career and all those things as a career as a researcher? My answer would be this. As you can see, this is the paper we published as the RAD at home, authored by Dr. Ananda Hota, who is the admin of the group, and you can see here all the members of the group, starting from Arvind, Sheena, Sai, Pratik, Amit, Pradipta, Alok, Akansha, Alkananda, Renuka, Shishal, Sushma, Shravini, and me, Nishchhal. Now, what was my contribution? Obviously, this is going to be the next question. My contribution was about a double radio galaxy and a misaligned DDRG. I'm going to tell about it later. So now, what is this? This is the NVSS image of the radio galaxy I found. You can clearly see that it is a simple FR2 radio galaxy, nothing much to say. The two radio lobes at the periphery, one optical host at the center. As you can see in this image, there's this red optical host at the center of the two. The contour levels, I'll be showing you the better image in a few minutes. Just keep hold. Next, what's so special? Speciality comes in this. Now, if you see this particular thing, okay, this is a simple drawing, this is a simple contour level. So what is so special? The speciality lies in the physics of the situation. This is a supermassive black hole. The dust is the accretion disk, and these two things, the blue flames that you're seeing, that are due to the synchrotron emission of the radiation of the electrons, which are rotating at relativistic speeds. Now, if you look back now, imagine there is a black hole here. Okay, it is radiating two lobes. This lobe and this lobe simultaneously. Then it stopped because there's nothing here. It is not a continuous emission. As you can see, there's a gap. So that means it radiated, it stopped, and then it restarted. That is episodic activity. Now, we cannot explain the episodic activity as because of a current physical phenomena. So that is why this is a very important observation and got published. Now the next one is misaligned DDRG. Again, nothing much to say. If you know the physics that I told recently, you can guess the feature. Yes, it is it is due to the precession of the black hole. It is rotating first in this direction, then in this direction. These two lobes are linear, and these two lobes are linear. But overall, that is forming weird like a S shape, you can say. Again, NVSS, as you can see, nothing much. TGSS, it shows the curvature, and that is why I was so much into it. Now this image is of a software called DS9. So let us just go to DS9 and see what do we have. How do we do the things? First of all, I open DS9. I open the FATS file. Look, for beginners, you can just say that DS9 is nothing but an image viewing software which also shows the coordinates of each point. Now first of all, I have to adjust the scale. That's fine. Now the thing I marked here, you can see it's okay. There are some lobes. I can see that the circle, it can be here. Okay, so what is so special about this? What is there? I can't see anything. So First of all, what I'm going to do is I'm going to change the color so that I can see the lobes. No. Okay, lobes are not visible. Bad choice. So let us change the scale. If I change the scale to log, now you can clearly see the color. I mean, you can see that there are 4 lobes. Now this is the circle. What is the size, angular size of this? I convert it into arc minutes. See that the size is approximately the diameter of the circle, which is 2.66 arc minutes. Now what? The next step is to, okay, this is RAD at home where we do all those things. I already posted in the groups, so I'm not going to post it again. So let us go to TGSS image viewer. We are going to go this, then image server, and now I'm going to enter the RAD of the image, that is 512.13.6 and 131.51.4. I want a 5 arc minute size, so I'm going to submit the query. Now I'm going to sky view because I also want to look for the optical host galaxy. 512.13.6 space 131 and 53.14. So now I want the image to be big. The image size, I want a 5 arc minute image size, so that wise I want a rainbow. Overlays, I want to make a RGB because I want to catch up with the optical host galaxy. So while choosing this thing, you can do whatever you want, but you can choose any arbitrary catalog you want, but it is advisable to choose on the basis of the wavelengths. Now I want to contour NVSS over it. Where is NVSS? Because NVSS is going to mark my source. Let it is 20.001. Then it can be 0.1, it can be 10. So now let us submit the request. Meanwhile the TGSS image is loaded, and as I had shown you, 2 lobes, multi-pair lobe galaxy. Skyview image is also loaded. Okay, the smoothing was not nice, but you can clearly see that there is a bright optical source. Now the optical source is so far that it has redshifted. That is why we are seeing it in red color. Now the advantage of choosing RGB, the colors on, the catalogs on the basis of the wavelength, was that here the red means that it is higher in wavelength. Okay, so that means it is a redshifted source, and these lobes. Now what do I do now? I'll post all these things in RAD at home like I posted here. Okay, this is a different source. We are working even now. I'm going to post it here. People are going to comment and blah blah blah. Things will progress. Like this was the science exhibition of which I was told to make the presentation. I hope you enjoyed it. Like this is a simple FR2 science day. These are the new members coming regularly, and our family is now about 632 members, and it is growing day by day. Let's see what we have in the future. Thank you.